So this is actually a simple motor which consists of coil. Right, coil. We wind it around the iron core, and then at the end of the coil here, so this part, so this is known as the commutator. So you see, if I turn the coil, the end, the two end will turn together with it. So it means that the commutator will turn together with the coil. Can see or not? This part. This is the commutator. This part. So that is the commutator. So you see, when the coil rotate, when the coil rotates, so it rotates together with the commutator. And then this end, okay, straight wire here, so this is a simple carbon brush, okay. So when the coil is in horizontal position, so you can see that the carbon brush is in contact with the commutator. But when the coil is in 90 degree like this, so the carbon brush and the commutator is not in contact. But later you see that the rotation will be in one direction, okay, and when it is in vertical position, it will still continue rotate, although current does not flow in the coil. So this is due to the inertia. Right, so I will just place the whole thing in between two magnets. So we have, can see or not, this is north pole, and then this side is the south pole. Right, so I just place the whole thing in between the north and south pole of the magnetdoor magnet, and then can see that here is the positive terminal, okay, connect to the DC power supply, and then the other end is connected to the negative terminal. Alright, so I switch on the power supply, see what happened. But first, we must make sure that the commutator and the carbon brush touch, okay, when they are in horizontal position. So I switch on first. I'm using 4 volt direct current power supply. See or not, it start to rotate, okay, but need to make sure it really in horizontal position first, okay, because we want current to flow in through the coil. Can see or not, it's quite hard, so I just touch this by using one hand. Can see there is a force acting, quite strong, but need to balance first to make sure it rotates. Okay. Can see it rotate. Let's say I use my 2 finger down here and then try to release. Hopefully it can rotate faster. There, it can rotate now. So don't forget to use your left hand Fleming's rule to determine the direction of the rotation. So if you have not watched my video on 3.2 force acting on current carrying conductor in a magnetic field, so please watch. Quite hard. Yeah, we need actually two people to help to hold. Try again. Can see? To increase the speed of rotation, okay, we can increase the current that flow through, and then also increase the number of turns of the coil. And then another method will be to increase the strength of the magnet. You can use more magnet, you can use stronger magnet. Alright? So that the force acting will be bigger, the catapult force will be bigger, hence the rotation will be faster.
So let's say you want your fan to rotate faster. So normally you increase the current that flow. Alright, so that's all.